There we go. So we're recording. So our lesson today on real numbers and radicals, the first thing that I want you to be able to do is to classify numbers. And we're talking about real numbers being numbers that you can tell me it's real, it's rational, it's irrational, it's an integer, it's a whole number, it's a natural number. So you want to be able to give me the names that a number would fall under. There is a really nice chart in the Educreations video that you will watch in the lessons, but I'm going to recreate that chart here for you today. So let's start with the idea that every number right now that you know is a real number. There are numbers that are non-real. They're called imaginary numbers. You'll learn about those in high school. Okay, but basically an imaginary number is a square root of a negative number, which you cannot calculate, so we do something about that. So right now, everything gets the word real. Everything you know, anything we ask you, real numbers. Now, real breaks down into rational and irrational. This is what you will be tested most heavily on. And I'm going to run out of room. Okay, rational and irrational. So that is what you will be tested most heavily on, is rational and irrational. So let's talk about what makes those numbers, each of those things. The easiest list to remember is the irrational number list, because there's only 3 things that you really need to remember. So irrational numbers are square roots of yucky numbers. How many of you remember that from watching my video? Okay, square root of yucky numbers. What I mean by a yucky square root is it's a square root you can't do in your head, like the square root of 12. Yuck. The square root of 52. Yuck. So those are irrational numbers. But the square root of 25 is 5, and we can do that one in our head. So that one's going to be rational. Okay? So the square roots of the good numbers that you can do in your head, or the happy numbers, if you want to think of them that way, there's a little happy face, kind of, sort of, okay? Then those are your rational square roots. But if it's a square root of a number you can't do in your head, or if you punch it into your calculator and it fills up your whole calculator with numbers, that's irrational. So far, so good? All right. Next, something else that makes a number irrational is it has pi as an irrational number, or anything with pi in it, like pi plus 2 or 3 pi over 7. All right? So those things, anything with pi in it is automatically irrational. Pi is the most famous irrational number that you know right now. All right? And the third thing that makes a number clearly irrational is what I call a forever decimal. All right, so a forever decimal, a decimal that goes on forever with no repeating and no stopping. If a decimal repeats, it's rational. And I spelled that wrong. Repeat. Repeating decimals are rational, and ending decimals are rational. All right, but the forever decimals that don't repeat and don't end are called irrational. In your software program for your skill checks, instead of calling them ending decimals, they are calling them terminating decimals. So maybe you've seen that phrase, terminating decimals, and you don't know what that means. Terminating means it stops, it ends. So 7.25, it stops, it ends, it's going to be rational. So that's the difference between rational and irrational. Rational on the left there also includes all fractions, all mixed numbers, okay? All whole numbers, all positive and negative whole numbers, which are called integers. Any questions so far? 1.3415724865798325. It goes on forever. It doesn't stop. And what happens is what's going on is a process of division where you never get the same remainder in a row. The same set of remainders in an exact row. Okay? So that happens. All right. I'm going to erase just a little bit of this here so that I can work on that list of rational side on the left there. So rational numbers, we're going to work on this chart a little bit more. Let's go back to red. Rational numbers include your integers, and it includes your whole numbers, and it includes your natural numbers. So, this is a very important order because you can go and say, all right, if a number is natural, then it's going to be natural and whole and integers and rational and real. Okay? It's going to be everything above it. If your number starts at the integer level, let's say it's -2, -2 goes in at the integer level, then you're going to go up. It's an integer, it's rational, it's real. Do you see how that track is going to help you name everything? So this chart's going to be very, very handy for you if you can track it and watch it and use it just in the right order. What's the difference between whole numbers and natural numbers? Does anybody remember? Whole number and natural down here at the bottom. You know the difference?
Isn't whole like 0, 1, 2, 3, and natural is 1, 2, 3?
Very good. Natural is 1, 2, 3, ... And whole is 0, 1, 2, 3. Do you have a really good way to remember that the 0 goes with whole numbers? Anybody got a good way? Can you see it? What do you want to do?
O looks like a 0.
Whole has 0 or O in it, right. So you'll remember that. Okay, so that's whole numbers. Continuing up with the purple there, integers are ... -2, -1, 0, 1, ... the other way, right? So we get our integers in there at -2. That's where integers start. And then, of course, we already talked about all those different things that a rational number can be. All right, I'm going to throw some things at you. All right, so not really. Don't duck or anything. How about the number 7? What's the lowest entry where 7 can fit? Natural. So 7 is natural, and then going up, it's also going to be, talk to me, whole, integers, rational, and real. Very good. All right, let's think about the -5. Where does he start? Integers. So integer and rational and real. Okay, let's talk about the number 0. Where does he start? Whole. So whole, then he's an integer and rational and real. Isn't that helpful? Okay. Again, this chart's right here. I'm going to post this link. And the video that I gave you that's already in Course Sites has this on it. It will benefit you if you know them in the right order. You're going to be able to use the chart. Any questions on classifying numbers? So far, so good? Lots of head shaking? Yes? Okay. Let's move on to square roots. You all are pretty good at square roots, really. The square root of 81 is 9. But in 8th grade, we ask you to then recognize that not only could the square root of 81 be 9, but it could also be, that's my and symbol, it could also be a -9. Because isn't -9 times -9 also equal to positive 81? All right, so as an 8th grader, we ask you to recognize that it's 9 and -9. All right? Sometimes we ask for just the negative answer. So if I write -81, square rooted, with the negative on the outside, that means I want you to give me just the -9 answer, okay? If I give you just 81, then I want just the positive answer. If I give you plus or minus radical 81, then I want both. I want positive 9 and -9. And sometimes in math, you're going to see that written like this, plus minus 9. Have you ever seen that before? It's actually in your book that way, okay? Plus minus 9 like that. So there's some ways to think about square roots. I want to expand on the square roots just a little bit, and I want to actually talk about the square root of a fraction in a couple of different ways. So what about the square root of 36 over 81? And I'm realizing as I walk around the room and help you that this is something you're a little bit challenged by, okay? So the square root of 36 over 81, this is what you do. I want you to pretend that it just splits, top and the bottom, and do both of the square roots separately. See that? That's not hard to do, is it? All right, the square root of 36 is 6. The square root of 81 is 9. That answer is not quite finished yet. What do I need to do? Simplify down to 2/3. So the square root of 36 over 81 is 2/3. Here's what I've been seeing students do. They grab their calculator and punch in 36 divided by 81, then they punch their square root button. And none of their answers on their skill checks look like this horribly long decimal that they get on their calculator. And they're going, I don't know how to do that. Okay, that's how you do those. So put down the calculator, even though you're tempted to pick it up, and just do that with mental math, okay? Here's another one. Similar to that, the square root of 1/9. The square root of 1/9 is going to be the square root of 1 over the square root of 9. What's the square root of 1?
1.
And what's the square root of 9? 3. So 1/3 is the square root of 1/9. Okay? Any questions on that? One more square root of a fraction, and I was actually helping Andrew with his math homework. He's my 8th grader the other day, and he goes, Mom, I can't square root 48. What do I do? And I can't square root 3, what do I do? So think about that a minute. What's an option? 48 over 3. Do you know what 48 over 3 is worth? Do you know?
16.
It's worth 16, isn't it? Because 48 divided by 3 is 16. So that fraction is actually, quite frankly, just the square root of 16, which is 4. That wasn't so bad, was it? All right, looks scarier than what it was. So there's some basic square root information on how to find some square roots. Keep in mind you're going to want to always be thinking about positive and negative square roots. And this is how you square root some fractions as well. All righty? Now the next topic is going to be estimating square roots. You're going to be asked to estimate, for example, the square root of 79. And your skill checks, whoever, can ask you, between what two numbers is the square root of 79? Is it between 3 and 4? Is it between 5 and 6? Is it between 7 and 8? Or is it between 8 and 9? So the square root of 79 falls where? Between what? And that's going to be your question. So here's how you handle that. You're going to take the perfect squares that you can do in your head that are right next to 79. Give me one of them. 9 times 9 is 81. So on the higher side, we have the square root of 81. What about on the other side, on the left? 64, right? 8 times 8, yes? See that? See what I'm doing there? All right. So we know that the square root of 64 is 8. We know the square root of 81 is 9. Where is the 79 going to fall? Is it going to fall in the middle? Or over to the right? Or over to the left? To the right, because 79 is closer to the 81, correct? Okay, so that's going to kind of hang to the right there a little bit. So we could estimate that the square root of 79 is going to be right about here, which would be about 8 point, what do you think? 8.9, 8.8, 8.7, and because we're estimating, I would actually take any of those answers. Would I take 8.5? No. Would I take 8.2? No. All right. So a couple of questions that you'd be asked off of this. First of all, between what two numbers does it fall? It falls between 8 and 9. Then, if you're asked to push that a step further and give a decimal, make sure you make it go to the higher end or to the lower end or smack in the middle. And that is estimating square roots. How you doing on that? Give me a thumbs up, thumbs sideways, thumbs down on that. Thumbs up, thumbs up, thumbs up. Got a couple sideways. Okay, we'll work on that. If you haven't gotten there yet, you will. All right, what's next on my list? I believe it's PEMDAS. Do you know what PEMDAS is? Please excuse my dear Aunt Sally, right? I would like to know if you know, where do square roots fit in? with the E, right. And what did I do? I spelled something wrong. What did I forget? Okay. DAS. Okay, so radicals or square roots fit in with the letter E. So you're going to do parentheses, you're going to do exponents and square roots, then you're going to multiply, divide, add, and subtract. So let's have several examples of that. Let's do 3 times the square root of 12 plus 4 minus 5. So there's a problem for us to try. Let's start in the parentheses. Then we're going to do the square root. What's the square root of 12 plus 4? Well, what's 12 plus 4? 16. So this is a 16. What's the square root of 16?
4.
It's a 4. So this whole thing here is worth 4. And then I'm still in my parentheses. 4 minus 5 will be negative 1. And then out here, 3 times negative 1 is negative 3. Notice I didn't give you crazy numbers. They're not big. I just want to know if you know the order. You will have simple numbers. They're not going to be huge, but please watch out for positives and negatives. Okay? So let's do a couple more examples of that. Let's try 7 minus 12 square root 1/4. Where do we start? P parentheses don't have any. E exponents and square roots. Yes. What's the square root of 1/4? 1/2, right? This is 1, this is a 2. So this is a 1/2. Now I have 7 minus 12 times 1/2. Who gets priority? Subtract or multiply? Multiply. What's half of 12? 6. And then 7 minus 6 is 1. Okay? How is PEMDAS with exponents and square roots for you? Good? Good? Any questions? All right. There is a video that I teach with this in it, so when you go through and look at these, you will get even more support on them. That is PEMDAS, order of operations with square roots, okay? Next. I've got more, but wait, there's more. Next. Here's the one that a lot of you are struggling with. How do I know? It's my job to know. I walk around and I see you trying to simplify radicals. And you're a little bit wishy-washy on that. So I'm here to clear that up today. Let's start with the radical 50. Do you know that radical is a fancy word for a square root sign? So you want to know why I'm saying radical all the time? That's the fancy word for a square root symbol. You're going to hear that in high school. They're not going to say the square root of 50. They're going to say radical 50. So if you can get used to somebody saying that now, you'll have it. Radical 50. Simplifying radicals is not picking up your calculator, punching in 50, and hitting the square root button. That's not what simplifying radicals is. And that's what a lot of you are doing. You show me your answer on your calculator, and you go, Mrs. Moore, I don't know which answer to pick on my skill check because nothing matches. Okay, I don't have anything close. So I'm here today to show you how to simplify radicals. Simplifying radicals means that you are going to take the number under the radical sign and you're going to split it into 2 numbers. And I want one of my numbers to be a beautiful, perfect square that I can do in my head, that I can find the square root of in my head. So what times what is 50? And one of those numbers is a beautiful, perfect, square rootable number. 25. So I'm going to put 25 times what? 2. Good. Now here's what you do next. And the one video that you watch about this does not teach it this way. This is the way I teach it. So if you like my way better, you come back and watch it. If you like the way the lady on the video does it, go watch her video if you're stuck. Okay, go watch it again. So what we do with that 25 is we go ahead and we square root it. And we pull out the answer of 5. See what I did there? All right. And then I have 5 radical 2. And that, my folks, is the answer. So the radical 50 simplifies down to be 5 radical 2. I will do another one of those. I will do several more, actually. Let's do radical 72. We want to split 72 into 2 numbers, one of which is a beautiful, perfect square that I can square root. Just use your math facts. 36 times 2. Okay, great. Good job. 36 times 2. We're going to square root the 36, pull out the answer of 6, and we're going to get 6 radical 2 as our final answer. Did anybody think about doing 8 times 9? Anybody? Okay, let's talk about that. Let's do the same problem, and instead of doing 36 times 2, let's do 8 times 9. So the square root of, or 9 times 8, 9 times 8. We're going to square root the 9 and pull out the 3. See that? So now I have 3 radical 8, and this is where your problem's a little bit different. Radical 8 isn't done. I can split 8 again into a beautiful perfect square of 4 times 2, right? So we're going to continue and do this again, 4 times 2, and we're going to pull out the square root of 4, which is 2. Does anybody know what I do with this 2 and this 3? You multiply them. Square roots and square rooting, all multiplying stuff. So this is now a 6, and underneath my radical symbol I have a radical 2. Hey, look at there, we got the same answer, right? So there's more than one way to get there. Doesn't matter which way you choose, as long as the number under your radical is simplified completely, you're finished.
So you just take the number divided by 2 and then square root that number?
Well, not always. If it was 40 divided by 2, you'd have 20, and that doesn't do you any good, does it? Okay, so you want to pick something that's square, that you can square root. You want to always pick one number that you can square root. All right, let's try one more of those. Let's do radical 120. A lot of things make 120, but I want one that's really nice that I can square root. So give me something times something is 120. What times what is 120? 60 times 2, but 60 you can't square root and 2 you can't square root. So while they do make 120, they're not helping my cause of trying to square root something. Okay, you want to try another set? So not 2 and 60.
I would say 40 to 3, but
Okay, 40 and 3, not really. Nope, 40 you can't square root, 3 you can't square root.
and then you got another.
Try another one.
But it's 30 or 4.
30 times 4, 4. We like 4, don't we?
Oh yeah.
Why do we like 4? Because you can square root. So, there we go. 4 times 30. Okay, so we're going to square root the 4 and pull out the 2. That gives me 2 radical 30. Now we got to think about 30. How about 4? Does 4 work with 30?
No.
Okay, what's some other square roots we like? Squares, perfect squares. 4, then 9. Does 9 work with 30?
No.
No. What's after 9? 4, 9, 16. Does 16 work with 30? No. What's after 16? 25. Does 25 go into 30 evenly? No. And then we're past 30, so we're done, right? All right, so the ones you want to think about are 4, 9, 16, 25s, 36s, 49s, right? 64s and 81s for really big numbers. But that is how you simplify a radical. Notice I never once had to turn this presentation off and go get a calculator, did I? All right. So simplifying radicals is the process of factoring them into a perfect square and another factor, and then square rooting that perfect square out. Okay, next. I'm going to add, subtract, and multiply, and then we're done for today, okay? So hang in there. You don't have to listen to me all day very often. Today's just one of those days, okay? So let's do adding and subtracting. Addition and subtraction. Now, addition and subtraction, before we get into the radicals, I want to review something with you. And here's what I want to review. In algebra, at the beginning of the year, we learned that 5x plus 3x equals what? 8x. How do you get the 8? You add 5 plus 3, right? What about the x? What do you do with the x? It's okay to say nothing. What do you do with the x? Nothing. You leave it alone, don't you? You just keep the x as it is, all right? Now, what about this one? X minus 4x equals what? Nope. Negative 3x. Thank you for saying negative. Okay. There's a 1 hiding right there. All right. What about this one? 2x plus 5y. Nothing. You can't do it. Why not? because they're not like. So in algebra, we have to have like terms, right? With variables, they have to be like terms before we can add or subtract them. Now the same is going to be true with radicals. Only instead of calling them like terms, we call them, here's a fancy word, radicands. C-A-N-D-S, radicands. They are like radicands. So before you can add or subtract, your like radicands have to be present. They have to be there. So here's an example. Radical 5 plus, and let's put a 2 in for there, 2 radical 5 plus 3 radical 5. Do the radicals match?
Yes.
Yes. So I'm going to add the 2 plus 3 and get a 5. And then I'm just going to keep my radical 5 as it is. I'm going to leave it alone. So 2 radical 5 plus 3 radical 5 equals 5 radical 5. We are doing arithmetic with square roots without punching them into our calculators. Got it? All right, let's try another one. What about 3 radical 7 minus 2 radical 7? 1 radical 7. Good. By the way, you don't really need the 1, so we can erase that off of there. Radical 7. The 1 doesn't do anything. All right, what about 7 radical 2 minus 12 radical 2? Negative 5 comes from 7 minus 12 right there. Okay, and radical 2. Good. Negative 5 radical 2. That is adding and subtracting radicals. I've got one more for you on that one. What about 5 radical 3 minus 10 radical 2? Can't do it. This one's done. Cannot simplify that any further. And to increase the difficulty, how about 3 radical 3 plus 4 radical 12? What's your first instinct? Your first instinct is to say, I can't do that, right? Because they don't match. Take a step back. What did we just learn that we could do with the 12? Simplify. Good. What do I split the 12 into?
4 times 3.
4 times 3. Okay, we're going to square root the 4. Pull out the 2. This is 2 times 4, which is 8 radical 3. So 4 radical 2 is the same as 8 radical 3. And now bring down, going backwards here. Bring that down. All right, now what's my answer? 11 radical 3. So be cautious with adding and subtracting just because they don't match. I mean, if they don't match, you can't do them. But that second one, we can make it match, can't we? All right, so we have to reduce it to make it match. Once we make it match, we can go ahead and add. One more, you ready? Breathe with me here a little bit. We're going to multiply, okay? Multiplication. Now, you can multiply anything. They don't have to match. There's no tricks. There's nothing that has to happen. If it's up there, you can multiply it. So nobody cares if they match or not when you multiply. Okay? So if we have the square root of 5 times the square root of 7, I am just going to simply get the square root of 35. I just multiply the 5 times the 7. Can 35 be simplified with perfect squares and all that? No, it can't. You do want to check that before you leave the question. Can it be simplified? Kind of like fractions. Is it in lowest terms? All right, what about radical 12 times radical 5? What do you get there? Radical 60. Can 60 be simplified? Yes, it can. Yes. 60 is 4 times 15. And how do I know that? Because maybe I picked up my calculator and I checked to see if it was divisible by 4 or 9 or 16 or 25, right? I tested it. So you can test that. The square root of 4 is 2. Cross that off and pull it out. 2 radical 15. So when we look at our original multiplication problem of radical 12 times 15, radical 12 times radical 5, we're going to get 2 radical 15 as our answer. Questions on that one? Questions on that one? Anybody? All right, one more type of multiply, then I promise I'm done. 3, whoops, that didn't show up very good, did it? I'll try that again. 3 radical 5 times 5 radical 7 equals 15. You do the outside numbers. 3 times 5 is 15. And then you're going to do the inside numbers. Radical 35. You cannot do any simplifying with radical 35. That problem is finished. So what's different about this one is you had outside numbers. You do the outside, you do the inside, you see if you can simplify. Any questions?